Okay. All right, so yesterday we did arithmetic sequences and series, and for those, we were adding a specific value each time. In geometric sequences and series, every time you go from one set to the next, you're multiplying by a value. That's really small. So you're going to have a common multiple for each of these values or terms in the sequence. What's the multiple in this example? 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So each time you're multiplying by 2. Sometimes people think of it as multiplying or dividing. If it's going down, you're multiplying by a fraction. You can multiply by 1/2 is the same thing as dividing by 2, right? So just keep in mind, if it's increasing, you're multiplying by an integer, and if it's decreasing, you're going to be dividing by a number or multiplying by a fraction. Okay? What's the next term in this geometric sequence?
0.0 16 times 16.
Not 16 times 16. Right, times 2, right?
Oh, you're right, yeah.
Mm-hmm.
How do you get from 10 to 2? Oh, I see. I get 10 to 2.
No.
Wait. Divide by 0.5, right? Or you multiply.
Times by 0.5.
Yeah. Right. What about in this one? 6, 3, 1.5, 0.75, 0.375. What is the common multiple?
Divided by 2? Yeah, so 1/2.
Right. Okay. So the reason why I want you to think of it as a multiple is because when you go to use your equations and your formulas, that's how that number is identified, as a multiple of. Okay? Record. Yeah. Okay. There it is. And what would this last one be?
-3.
Okay. So what's our next value?
-729.
Wow, magic. Yeah, that job.
Mad skills. All right. I think there was actually a... Okay, so why a geometric sequence? Because it's like increasing the dimensions in geometry. So a line is one-dimensional and has a length of r. In 2 dimensions, it's squared. In 3 dimensions, it's cubed, etc., etc., etc. Okay, you can have multiple dimensions.
Is this on the packet?
No, I took out a bunch of the big images, I think. I just left it with the examples on there. Okay, so, and geometric sequences are sometimes called geometric progressions. Just so you're aware of that. Hello. Okay, so geometric sequence, like we said, it has a common ratio. That's the value that we're multiplying by each time. Okay, the terms of the sequence can be represented same way, A1, A2, A3, but it's always going to be times R. Okay, and that R value is never going to be 0. So in example 1, it says determine the common ratio and find the next 3 terms in each sequence. So what is the pattern that's going on here?
Times -1/2.
Okay.
There we go.
So our R, our common ratio, is -1/2. And the next 3 terms would be what?
-1/16. Or, geez, -1/8.
Okay.
And then 1/16. And then -1/32. I don't know.
32nd, but yes. I know my husband's a dentist, but all right, and then
That was totally intentional.
sure it was. Okay, so what about this one? It's a little more complicated, or is it?
Oh, it's just like R1 times 3 each time.
Right, so if I factor out a negative 3 here, I have r minus 1. If I factor out a 9 here, I have r minus 1. And if I factor out a 1 here, I have r minus 1. So that kind of helps you to see it's 1, then it's negative 3, then it's 9. It's got that common factor of r minus 1, but that's not changing each time, right? So for B, we're really multiplying. Our common ratio is going to be negative 3, because 1 times negative 3 is negative 3, and then negative 3 times negative 3 is positive 9. So our r is going to be negative 3. Benjamin's falling out of his chair. And what's the next 3 terms going to be?
Negative 27 R minus 1.
Right, so negative 27 r minus 1.
Then whatever that is times 3.
Yeah, I don't know.
It'd be 91.
Yeah. Positive.
Yeah. And then that times 3 is 273.
Very good.
Bang.
And negative, right?
270.
Negativo. And we could theoretically distribute each of these so that it's in that same form as the original. But we're not going to for now, because we know what we know. Okay? So same goes on if we're looking at the nth term of a geometric sequence. There is a formula for that. That's what we see here. So if it says to find an approximation for a certain term given a sequence, this is going to help us. For example, so it says find an approximation for the 23rd term in the sequence. So we can always think of this as A2 divided by A1 or A3 divided by A2 to find out what that common ratio is, right? So what do we get here? It's negative 179.2 divided by 256 is negative 0.7, and then you want to just check yourself before you wreck yourself. Negative 0.7. Okay, so our common ratio is negative 0.7. What was it called? In geometric, it's a common ratio. In arithmetic, it's... Vector. No. Okay. All right, so if we're looking at A sub n... Oh, no, it was the 23rd. Well, let's write the formula. So it's the first term times r to the n minus 1. So if I'm looking to find the 23rd term, our a sub 1 is 256. Our r is negative 0.7. And n minus 1 is going to be to the 22nd power. And whatever that is equal to. Anybody? Anybody have a calculator out? Anybody doing this? Anybody? Anybody? It's what?
0.1.
0.1? Is it 0 after that, or we're just going for 1 decimal today?
Oh, it's 0 after that.
Okay. All right.
Can you go bathroom?
Yep. Are we good with this? Okay.
Yeah, it's 0.1000.
Perfect. Thank you. So write a sequence that has 2 geometric means between 48 and negative 750. So now that I'll do this the proper way instead of the wrong way. two geometric means in between. All right, so we have our equation, a1 times r to the n minus 1. We have our last term, which we can represent as a sub n, and this 48, which we can represent as our first term, right? So if I do that, I have negative 750 is equal to 48 r to the n minus 1. What is my n going to be? In my a sub n, which number term is that? This is my first term, second, third, fourth, right? So because this is my fourth term, it's kind of like saying a sub 4, right? So that's why here, if I think of it like this, then my n is 4, and I could say r to the 4 minus 1. Okay? That allows me to actually figure out what my r is. Okay? So if I divide by 48, and then I have to take a cubed root of that, correct? To get r by itself. I got negative 2.5.
How do you do cube root on this calculator?
So anytime a square root like this is the same thing as having a little 2 here. And so it's the same as saying x to the 1/2, if you remember any of this. So the, So if you have a square root of something, if you're trying to do a cubed root of something, what do you think it'll be?
X 1/3.
Exactly. So in your calculator, on your graphing calculator, there's a little caret symbol that looks like this. So it should be something like this if you're trying to do divide. It's right below the clear button on the right.
Oh,
Do you see it?
yeah, that works.
That's the best way to do it on these. Okay. Oops. All right, so we've figured out the common ratio, but we didn't actually write the sequence of the series. We need to go back and fill in those extra numbers. So I have to do 48 times negative 5/2, right? And if I do that, I get negative 120. And again, if I multiply by negative 2.5, I get 300. And I could check myself, multiply by negative 2.5 again, and I'll get to negative 750. Okay?
Wait, can I see that last thing?
No. So find the sum of the first 10 terms of the geometric series. So the first thing we need to do is figure out what that r is. What would that be? And if you're not sure, don't forget, it's just a matter of taking the second term and dividing it by the first, or taking the fourth term and dividing it by the third, whatever it is. Okay? So in this case, 48, negative 48, divided by 16 gives us negative 3. That formula for the summation is a1 minus a1 times r to the n, all over 1 minus r. So now I want the 10 terms, first 10 terms. So s sub 10 is what I'm looking for. My a1 is 16. My r is negative 3. And it's just a matter of plugging in.
Sorry to interrupt, but do you have my free response and no calculator questions?
I didn't staple it to that.
No.
Okay.
She does. Thank you.
Yeah. All right. What do you think? One more? Why not?
Yes, ma'am.
Not bad for a Friday. Hiroshi wants to begin saving money for college. He decides to deposit $500 at the beginning of each quarter. So that's 4 times a year starting in January, right? In a savings account that pays an APR of 6% compounded quarterly. The interest for each quarter is posted on the last day of the quarter. Determine Hiroshi's account balance at the end of 1 year. So we're trying to find after 4 iterations, right? Because it's quarterly. So my N is going to be 4. My R, my rate is going to be that 6%. So how do you represent 6% of the total 4 times a year?
6, like,
So you start with the amount that you have
yeah.
plus 6% divided by 4. Very good. So if we just write that as a decimal, it's 1.015. Easier to work with.
Wait, why is it that though? So 1 is the money you put in, right?
The total, yeah. Mm-hmm.
So that 1 is going to be the 500? Or like,
In this case, yeah.
okay, so and then the 6% is always 6%.
Mm-hmm.
Divided by 4 because it's
Quarterly.
Okay.
Yep.
Wait, is
So APR.
So to figure out A1, it's going to be 500 times 1.015. That's why we have the 1 there, so that we could use it in any case.
Okay.
Okay.
One last question.
Mhm.
Why is it divided by 4? Is it because the work problem makes it like 6% at the end of the year, or is that because? Is that what?
Divide by 4 because it's quarterly. It's 4 times a year that we're compounding the interest. Do you know what it means when it says compounded interest?
The rate
Okay.
increases on itself.
Right. Well, right, exactly. So you're putting in $500 on January 1st. When comes April 1st,
Yeah,
that
500.
percentage is going to change, right?
530.
Right. It's going to be based on the increase that you made, right?
Yeah.
So, I mean, basically, this is why people invest money in stock market versus putting stuff in a savings account, because the amount of money that you're going to make is not very much.
Yeah.
It's a safe bet because, you know, banks aren't going to go under unless the economy is really, really bad. But you're not going to lose your money.
Yeah.
Whereas in the stock market, you can make a lot more, but it's a big risk also. So, you know, people make professions out of that. If you're good at what you do and you study up on it, you can make a really nice living doing it. So to figure out that first term, we just have to do our amount of our deposit, the initial deposit, 500 times 1.015, which gives us 507.5. And then if we want to figure out what the sum is at the end of 1 year, the account balance at the end of 1 year, I have everything that I need because I have my A sub 1 minus A sub 1 times R to the 4th term, right? And so if we do that, then we have the amount of money that we made each quarter is posted, the sum for the year. Okay.